All right, we'll get started. I'm just going to briefly go over exam 3. You should have all received your graded exam. I don't know, when did I send that out? Last week, maybe on Friday. So you should all have that. I just want to go over it just because the final exam, which I'll talk about today, will, include topics that, were covered on this exam. Okay, so let's just kind of go through it. So first question, I wanted you to figure out the x and y intercepts of the following two equations. So this equation here, it's a quadratic polynomial, right? So you have x squared minus 4 is equal to y. So that's actually going to have two x-intercepts, right? Because if you were to solve, if you plug in y as 0 and then solve for x, you get two values, 2 and negative 2. So the two intercepts are going to be 2, 0 and negative 2, 0. And then for the y-intercepts, you're only going to have 1 at 0, negative 4. Some folks, I think I might have only taken a point off. I mean, when I'm asking for an intercept, I'm looking for a coordinate. So if you only gave me the values, I'm trying to ascertain whether or not you understand what I mean by intercept. So you had to give me the points as your final answers. And then part B this was just a line. So you just, again, for the x-intercept, you plug in y as 0, you'd get 12. So 12, 0 is the x-intercept, and then plug in x as 0, you get 0. Negative 5 is the y-intercept. Okay, so that'll be important because the intercepts mean things, right? So like in this math class, I'm sort of trying to give you the tools so that when you go to your upper level courses, this is something you're going to do a lot because the intercepts mean things, all right? If you're talking about an economics problem or some type of statistical problem, these intercepts are important. So that's why we're teaching them in this class, and that's why I sort of was focusing on them. Same thing here with the domain. Domain is an important thing, and I think every exam you had to find the domain of something. Okay, so I gave you two functions, and you had to find the domain. The first one, I gave you a rational expression, but the denominator was just a number, so you really could ignore it in terms of determining the domain. The only thing you had to look at was the radicand in the square root that was in the numerator. That has to be greater than or equal to 0, so that means x has to be greater than or equal to 0. So that in interval notation looks like this with a bracket 2, comma, positive infinity, parenthesis. And then B, this is a line. So this was just to check, did you remember? And again, you could have your notes on this. The domain is all reals. And how do you put that in interval notation? Well, it's negative infinity to positive infinity. So I may have taken a point off if you just said all reals. I was looking for interval notation. All right, so again, these number 1 and 2 are going to be important later on in your future classes. Even though if you don't think so now, trust me, you'll remember me saying this in those classes. Now, number 3, I gave you a function, and I wanted you to find the average rate of change as x changes from negative 3 to negative 2. So again, I gave you the equations up top. You just had to identify this one here that my mouse is near as the average rate of change equation. Figure out what f of negative 2 is and f of negative 3. So that was also just checking to make sure that you understood how to plug in an input to a function. So you take those two outputs, plug them into this equation here, and you should get negative 5. Okay. And then B is find and simplify the difference quotient of f of x. So if you have to take Math 107, this is something you're going to see again when you eventually figure out how to take what's called the derivative of a function. So it's important that you at least see the mechanics of how to get to that point now. So you have to use f of x plus h minus f of x over h. So you have to essentially plug in x plus h in the function, figure out what that looks like, and then plug that big thing in here that I'm circling here with my mouse into the difference quotient and then just simplify. And you end up with a 2x plus h. Okay? So any questions on that first page? We all right? Okay. Number 4, you're going to do a lot of things like this a lot where you're given an equation and you might not know what it looks like. So what you're going to do is plot, just pick random x values. Now, these aren't random x values. I chose x values so that you would get whole y values. So you didn't have to worry about decimals, so it was easy to plot. And, section 2.7, we actually looked at what an absolute value function looks like. And if you remember, just as a nice review, right? Section 2.7 was on transformations. So x minus 7 is a horizontal shift to the right 7 units. So you're going to see that instead of starting at the origin, we start at 7, 0. And the 1/2 means it's going to widen, right, or stretch out. All right, so this was kind of a horizontal shift problem. But even if you didn't know that, you can go ahead and plot points, and then, everyone, I mean, I didn't take any points off for how messy the graph was, but it's essentially just 2 lines that originate at 7, 0. And then we had our section 2.1 problems where you're given some coordinates and you want to determine the type of triangle those 3 coordinates create. And this one was scalene because there were no sides that were the same. And then again, number 6 was a gimme. It was just figure out the distance between those 2 points, and then the midpoint, you're just plugging numbers into a formula. Now 7, you're going to test whether the following function is odd, even, or neither. So you had to show me 2 tests. The even test, the odd test, and then it turns out they're neither even nor odd, so then the answer would be neither. And then number 8 and number 9 were line questions. Again, you're going to see lines everywhere if you in your economics classes when you take them if you haven't seen them already. So the first one was just write the equation of the line given the point and the slope. First one was pretty self-explanatory. Now number 2, M is undefined means it's a vertical line, right? So you have to take the x coordinate and just say x equals 2. Right, that would be the equation of a a vertical line. And then again, part C was just very self-explanatory. Just plug it into the point slope formula. All right, number 9, again, just slightly different ways to write the equations of lines. The first one was I gave you 2 points. So you had to know to calculate the slope, and then again, just use point slope form, no problem. Part B was actually out of the, I think it was the same 2.6, the same section as piecewise functions. Instead of just giving you coordinates, I gave it the coordinates in function form. So really part A and B were the exact same type of problem, right? F of 0, 4 means the coordinate 0, 4 exists on that line. And then f of negative 3 equals 0 is negative 3, 0. And then you repeat the same process you would have done in part A. And then lastly, it's write the equation of a line passing through point 24. That's parallel to another line. So you had to find the slope of that other line, which turned out to be negative 1/2. And if the line you're trying to write the equation of is parallel to it, they'll have the same slope. So we use that m equals negative 1/2 over here with the 0.24, and we wrote our equation. And then lastly, number 10 was our piecewise function. So you just have to take each piece and plot it. So I tried to make it as simple as I could. So when x is less than negative 1, so by less than at x equals negative 1, we're going to have an open circle, and it's just going to be 2 all the way to negative infinity. So that's why you see this line going all the way to the left. And then from 0 to 4, where we have a solid circle at 0, you would have started with an open circle at 4, and it's just a line with slope 2x. So you have to really figure out what's happening at 2x when x is 0. Well, it's 0, so you're at the origin. And then what happens at 2x when x is 4? Well, you're at 8, so that's how I knew to go up to 8 here. So there's your line. And then finally, it's just 8 constant all the way to positive infinity when x is greater than or equal to 4. So this turns out to be a solid circle. And you just go all the way to infinity. Okay? And then the domain, negative infinity to negative 1 with a parenthesis because we don't include 1. And then we start up again at 0 with the bracket and go all the way to positive infinity. And then we include every value between 0 and 8 and the range. Okay, folks, so that's exam 3. Any questions, anything I can talk about with regards to the content from exam 3 before I continue today? Everyone feeling all right with everything? We're all right? Beautiful. What was I going to do? Okay, beautiful. All right, so here's my plan for today. The last section that we're covering is section 2.9, and I was almost finished with it. So I'm going to finish off section 2.9 and then talk about the final exam. All right, so however long that takes is how long we're going to be in class. If that takes all the way to the end, that's fine. I don't think it will, but depending on the amount of questions we have, we'll see what happens. So I'm just going to start by going over section 2.9 again to make sure everyone's aware of what a one-to-one function means, because otherwise it's could be confusing. So what does it mean if a function is one-to-one? So here's the definition I gave. If all of the elements in the domain, so this means all of the x values, if all of those x values produce a unique y value, then we say that function is one-to-one. So the example I give over here was this line, this graph that you see on the left. If I chose any x value, let's choose this one, right? We'll call this one x3, right? When I go up here on the line, it has a unique y value. So if you can pick any x value and get a unique y value, you're one-to-one. So in my other example over here, I chose this point here and this point here, which have the same y value, but that same y value corresponds to two different x values. That function is not one-to-one. All right? So if you're not given the graph, we need a way algebraically to figure this out. So this is the process to determine if a function is one-to-one. So I gave you this example of a line. So we know it's one-to-one, so we know what to look for. So here's this line. So here's all you do. You're going to plug in x1 and x2 into a function, and you're just going to choose x1 and x2. Just leave it at that. And then, so you see you get this second line here where you have the same function, but instead of x, you're just subbing in x1 and x2. And what you're trying to do is reduce the equation to its lowest form. When you reduce that equation to its lowest form, if you get x1 equals x2, that is the magic solution that allows that function to be one-to-one. So that's how you do it algebraically. You take your original function, plug in x1 and x2, set them equal to each other, reduce that equation, and if you get x1 equals x2, you're good to go. So I gave you another example. G of x equals x squared minus 1. We plug in x1 and x2 into the function. So you see that we have x1 squared minus 1, x2 squared minus 1. And I ended up solving for x1 and saw that x1 has two solutions, meaning x1 does not have a unique y value because there's two of them. And I graphed it there to show you that it's a parabola. And of course, right here and right here, we call that x2, x1, has the same, same y value, not one-to-one. Okay. So why do we care about one-to-one functions? Well, our ultimate goal is to be able to figure out the inverse of a function, because they are useful, again, when you apply these things. So I gave you the notation for inverse, right? So if f is a function, f raised to the -1, so don't think about that as being an exponent. It's just the notation we use for inverse functions. And I gave you the two basic properties. And we used this open circle operator, which was the composition operator, which we learned back in section 2.8. And all that means is we're going to take the inverse function and plug it in as the input to the original function. That's all that means. And you could do it in the reverse order. You can plug the original function into the inverse function, and then the result should just be x. So I gave you an example. I said, okay, if f of x is 2x plus 3, and g of x is x minus 3, are these two functions inverses of each other? So here's what we did, right? We're going to plug g as the input to the function f. So you see that I have f of whatever g is, x minus 3 over 2. And then we go ahead and solve it, and we end up getting x. So we know g of x is the inverse of f. We reversed the process and said, okay, now I'm going to plug in f into g. So here's what f is, 2x plus 3. It's going in as the input to g. Again, and we just simplify everything. And again, we get x. So that also means f of x is the inverse of g. And that's where we left off, okay? So just to review, one-to-one function, what that means, and how to determine what a one-to-one function is, and then to check to see if functions are inverses of each other. So the last thing for this section that we just didn't get to yet, I don't know if you, can you see that green that well up there? Let's see, let's go with purple. That's probably a little easier to see. Perfect. Okay, so let's talk how to determine the inverse of a function. And this is the last new material for the course. So how do we do this? Okay, so let's say you're given a function. And again, we're going to start with one that we know is one-to-one. So here's a function. F of x equals 6x minus 7. I'm going to call this step 1. F of x must be one-to-one. So in order for a function to have an inverse, it has to be one-to-one. So just as, you know, another review of the process, you go through it. We're going to do f of x1 equals f of x2. Plug that in. 6x1 minus 7 equals 6x2 minus 7. The 7's will cancel out. And then we get x1 equals x2 after we divide by 6. All right, so this result means f of x is one-to-one. So we're good to go to continue with the process. If you're ever asked, find the inverse of a function, and then you find it's not one-to-one, you can't find the inverse. Okay, so now we're going to go ahead and find the function. So here's what we're going to do. We're going to replace f of x in the equation with y. So all that means is we're just going to make it an equation. Y equals 6x minus 7. All right. Next step, we're going to interchange x and y. So we're just going to flip where they are. So instead of having y equals 6x minus 7, I'm going to have x equals 6y minus 7. So I just flip the location of the variables. And then now we're going to solve for y. All right, so I'm going to move that positive 7 over with the x. So we have x plus 7 equals 6y, and then y equals x plus 7 over 6. And then the last step, I'll put it off to the side here, is to replace y with f raised to the negative 1 of x, because we've now found the inverse of the original function. So we have the inverse of x, the inverse of f of x is x plus 7 over 6. All right, so there's our inverse function. Okay. Now, if you were to go ahead and do this, and I'll do it just in this case, if we wanted to check to make sure we got the right function, you could do f composition of the inverse function we just found of x, and see, does that equal to x? And if it does, we've correctly found the inverse. So let's just in this case try it. So what we're going to do is we're going to plug in x plus 7 over 6, the thing we just found in, as the input to the original function f. So we'll get 6 times x plus 7 over 6 minus 7 The 6's here just cancel out, and we get x plus 7 minus 7, which is x. So boom. So there's a good check to see if you've correctly found the inverse of a function. Okay? So they're the steps you got to take. Not too bad. So let's try another one just to reinforce some of these steps. So here's another example. Here's the function. F of x equals negative the square root of 9 minus x3. So what we want to do is determine its inverse if possible. So again, when I give you functions, not all of them have inverses. So this one may have it, this one may not. So we'll see. Okay, so again, step one, we need to figure out if this is 1 to 1. So we're going to do f of x1 equals f of x2. So this one's, kind of looks complicated, but it really won't be too bad. All right, so the negative signs are going to cancel out on each side. And then couldn't I just square both sides of the equation to get rid of the square roots? I could. So I can end up just getting 9 minus x1 squared is 9 minus x2 squared. Clearly the 9's are going to cancel out. And then the negative signs in front of the x's are going to be canceled out. So we have x1 squared equals x2 squared. And then again, if I solve for x1, I get plus or minus x2. I'm sorry, the plus or minus, that plus or minus x2, which means that this single x value has two y values, right? Which means this function is not 1 to 1. So it has no inverse. Okay? So that's your first check. If you get to this place where you see, this x1 value corresponds to a positive x2, but then also that same x1 value corresponds to negative x2, that means there's no unique y value for that x coordinate. I believe if you plotted this, it's half of a circle. I think it looks like this. So clearly, right here and right here have the same y value. Okay. So that one doesn't have it. Okay, so you just move on and say there's no inverse. Simple. All right, let's actually do one where you actually get an inverse. But we'll involve a square root. Just so I don't want you to think all square roots, work out the same way. So how about this one? 4 minus the square root of x. So we would actually know, just as a review, what would this look like? Here, I'll even do this. The square root of x was one of those common functions we talked about in section 2.7. It looks like this, right? That's what the square root of x looks like. How about using the transformations from section 2.7? What does the negative sign in front of the square root of x do? What do negative signs do? Who remembers? Did you ever hear that? No. Yeah. Flips it across the x-axis. All right, so we know that. And then what does a positive 4 up here do? That's a vertical shift, right? Is that what you're going to say? Vertical shift in the positive 4. So I'm going to go up 4. And then from here, it's just basically going to do that. Okay? So from the graph, it looks like it's 1 to 1, right? So let's go ahead and just check it to be sure. So again, f of x1 equals f of x2. So 4 minus the square root of x1 equals 4 minus square root of x2. The 4's go away. You could divide out the negative signs, square both sides. You're going to get x1 equals x2. All right, so there's the magic result. showing you that you have all unique y values for any x value. All right, great. So now it's time. What was our second thing? We wanted to replace f of x with y. Okay, so we're going to do y equals 4 minus the square root of x. Ooh, it's moving on me. 4 minus the square root of x. All right, that was that step. Step 3 was to interchange x and y. So you have x equals 4 minus the square root of y. Step 4 was to solve for y. All right, so I'm going to move that x over. So x minus 4 is equal to negative square root of y. I don't like that negative sign on the right-hand side, so I'll multiply everything by negative 1 and get 4 minus x equals the square root of y. And then finally, to isolate y, I'll square both sides. So we'll just have y equals 4 minus x squared, or 4 minus x all squared. Okay. And then the last step, instead of having y, we're just going to replace it with f to the negative 1 of x, which is just saying that the function now is the inverse of the original function, and it's 4 minus x squared. Okay. Now, what's interesting, well, I don't know if you think it's interesting, but let's see. I don't want to, I'll do it in green, dark green. Okay. Now this guy here, again, from section 2.7, this is easy to graph. We know what x squared looks like. That's the base function. So what's going on here? What's 4 minus x squared going to look like? So again, here I'm going to put the original function, which was basically this, all right? That was the original function. And then now we're going to have a horizontal shift in the negative direction, right? Because this 4 right here is a plus 4, but it's inside the thing that's being squared. So instead of going right 4, we're going to go left 4. And then we have negative x, which means we're also going to flip it across the y-axis. So we end up getting this. That's the inverse. Okay. Now graphically, there's interesting things like there's an asymptote here, but you don't care about any of that because we're not looking at applications. But there's a lot of interesting things that you have when you do these inverses. Okay. All right. So that ends section 2.9. Now today there was a homework due on sections, I believe it was 2.7 and 2.8. And again, I'm not going to look at it probably till tomorrow. So if you haven't gotten it in today yet, get it in today. That's going to be the first homework for the final exam. Now, I wanted to give you another opportunity for homework just because, remember, the homework is just extra points to the exam, and I think everyone likes that. So, and this is not a long homework assignment. So, for end of section 2.9, and I already put these, I took a picture of them. They're already on D2L. It's just 5 problems. So, it's 29, 31, and then for 43 through 47 odd, I want you to do parts A and B only. Okay? 5 problems, no biggie. Again, you're going to be, trying to find the inverses. So again, you'll be checking if the function's 1-to-1, going through the same process I was going here. You don't have to graph anything. I don't think it says that. And just, find the inverse function. Okay, so there are those 5 problems. I'll make those due Thursday, okay? Everyone has a reading day, and there's only 5 of them. You can probably get them done today. And again, I'll make that a 4-pointer, right? So you'll be getting a 4-point bonus on the exam when you hand in the homework in that was due today, and then plus this 4-point bonus. So you can get 8 points on that final exam, which, it's pretty good, all right? So any questions about 2.9? Yes, sir. Oh, sorry. I have that right here. This is page 304. Okay. All right. So that's 2.9. All right, so if there's no questions, let's talk about the final. All right, I already told you it's going to be virtual. Let's see, how do I get out here? I already told you it's going to be virtual. Let me give you sort of the makeup of it. Okay, as a reminder, it's Tuesday, November 24th. We're going to keep the time just because I don't know what other times you guys all have finals that day. So it'll be from 8 a.m. to 10 a.m. And again, it's virtual just like exam 3. So I'll try to send it out around 7:50, 7:55 just to make sure it gets to everyone's email inbox on time. And I'll probably give you till about 10:05, 10:10 just if you have issues, you know, taking pictures and uploading it or scanning it or whatever you're going to do to get that to me. Okay? So here's the breakdown. Just as a reminder, too, the final exam is 20% of your final grade. So as of right now, you have 80% of the grades through the course, right? So this is 20%. So each exam was about 15%, so this is a little bit more. So it's going to be a little longer. I'm making it 15 problems, and I'm going to talk about the breakdown. Because we solved a lot of problems, right? A lot of problems this semester, okay? 15 problems. So 3 problems will be from sections 2.7, 2.8, and 2.9. All right, the ones we just completed after exam 3. So I think that is probably fair. So that's, you know, 1/5 of that final exam is just that the stuff that you weren't quizzed or examined on yet. All right, now there'll be 4 problems. Guess I'll just use quotations here from each of the exams. And if you remember any of the reviews when we talked about the exams, they were pretty much all the problem types anyway, right? So what I would do if I were you is focus on going through those exams and making sure you can do all those problems, okay? Will you see identical problems from those exams? That's a possibility, but I could change some questions just to ask some slightly different things. But I think if you focused on those 3 sections, 2.7 through 2.9, and then really just focused on what the content was from exams 1 through 3, that's what you're looking at for the final exam. Okay, 15 problems. And what I'll do is I'll just grade it out of 150 points, and that way each problem's 10 points. So it'll be out of 150 points. So each problem is worth 10. All right, any questions about what I just described? Trying to make it as simple and clear as I can. That's all good with everyone? Okay. The floor is yours. Does anyone have any questions about anything? What could I answer before we're done with class today? Aside from, I hope that the class wasn't a huge burden. But I hope everything I did was fair in terms of, you know, your grades and given the opportunity for the homework. And how did you like that homework policy? Right? I mean, I feel like it kind of made you do the homework because you did it, right? So anytime people do homework, I'm happy about it. And then the grade is sort of inputted into the exam that way. So that's okay? Like, you think if I continue that in other classes, students would be positive about that? Okay. All right, well, that's good to hear. Because I kind of thought it was a unique policy. I'd give it a shot. Anything else? All right, well, folks, I wish you a happy Dead Week, I guess, right? And have a good reading day Thursday. Look for an email from me. And by the way, if anyone has any questions between now and next Tuesday, email me. We can Zoom. I can go over whatever you want. Hope you had a good class this year, and I'll see you around campus. We'll be back in the spring, so don't be a stranger. What's up? Sure.
So, finding f of f, how do you do that? Do you just square like that?
Here, show me. I'll put it right on here. Show me the problem.
73 from the homework. F of f equals x squared.
So it's f of... Can I just look at your paper?
Yeah,
Is that
right.
okay? Oh, okay. F of x squared?
Yeah, of x squared.
Yeah, so, okay, so what you would do is, whatever the function was, what was it? X... What was the original function?
I probably have it. Sorry. It was a
No,
little
it's okay.
foggy. Right here. The original function was x squared.
Just x squared.
Yeah.
Oh, okay, so here's what you would do. The first thing you need to do is to say, okay, I'm going to plug into the original function f of x squared. All right, so let's figure out what that would be. That would be x to the fourth, right?
Yeah.
Okay. Now I'm going to plug in x to the fourth into the original function, which is
X
just
squared.
f of, it will just be x to the eighth, right?
Oh, all right.
See what I mean?
All right.
So you just start on the right and do the first thing. So you do f of x squared, figure that is, and then plug that into the, right? Because you could have something that looks like this. Not that I'd give it to you on an exam, but you could have like
Yeah.
tons of things, because that's applicable to different things. But that's what you do.
All right. Thank you.
All right? Yeah, no
I
problem.
appreciate it.
Yep, see ya.
Have a good break.
You too.